Hey everyone, this is Unit 5, Notes number 8, more on integration. So, you guys have had a lot of exposure to what an integral is, how to find it analytically, graphically as well, but maintaining the context, right? That's what I want you guys to understand there. So, here are some other problems that you may run into. These are very common problems that you guys will see on the AP exam. So this kind of serves as like a AP prep, but it also reinforces what you guys have been learning throughout the last few sets of notes. Okay? All right, so here we go. Go ahead and write down the FLT, and whenever you're done, press play. So we're going to revisit the idea of evaluating two different ways, analytically, which is just algebraically, and graphically by looking at a picture. Okay? And then what does it really mean when you incorporate derivatives with integrals, right? So we did a little bit of that before with the fundamental theorem of calculus. I think it was part 2, when you take the derivative of an integral. So you'll see a little bit of that as well. But here we go. Okay, so here's an analytical type of problem, okay? So here, they give you a few ideas. They tell you that some function, its integral from -10 to 1, -1 is 18. They give you some other facts, and then they ask you about another integral, a very popular problem that you'll see in the AP exam. So here's the first thing you want to do, okay? First thing you want to tackle is you want to take a look at all three integrals, okay? Now, understand that that integral is definitely backwards because the larger value should be on top. But we're going to ignore that just for now, okay? What I want you guys to think about is with these three bounds, which one covers the most distance? Okay, so for instance, if we're going from -10 to -7, that's like a distance of 3 steps. Okay, which one here has the greatest distance going from one number to the other? Press play whenever you're ready. So here, from -10 to -7, that's the distance of 3. From -1 to -7, that's just about 6. But notice right over here, from -1 to -10, that's a distance of 9, okay? So you always want to start off with the integral that covers the most. So in this case, we're going to start off with this one right here, okay? So here's what you do. Almost always are they forcing you to use that third property, okay? And I'm going to remind you guys here. So if you're going from, if you're taking the integral from 0 to 5, and then we take the integral of the same function from 5 to 20, that's the same thing as you starting at 0 and going all the way to 20. Okay, this was that third property if you look back in your notes. So we're going to use this idea, okay? So we're going to start off with the largest one. So going from -10 to -1, okay, of f of x dx, that's going to be the same thing as going from -10 to, I'm going to choose -7 here because I noticed that that is the other stopping point, okay? Right, of f of x dx. And then I'm going to continue from -7 all the way to -1 of f of x dx. Okay? Okay, so make sure that you replay that until you get it, okay? So here's what we know. We know, and let me get rid of all of these highlights so that you guys can see a little bit better. We have information regarding this. Okay, I know that the integral of f from -10 to -1 is exactly this right here, and it's equal to 18. So what am I going to do? I know that that value has to come out to 18. All right? Okay. Now, this right here, I kind of have. It's kind of right here. But think about how that's a little bit different, right? So if you guys notice, here I went from -10 to -7, but over here I went from -7 to -10. The bounds are backwards. But if you guys remember, there was a property that allows you to switch the bounds as long as you account for a negative. Okay? So if you know that the integral from -7 to -10 is -10, then the integral from -10 to -7 will be a +10. It's the opposite. Okay? Make sure you guys understand that before you move on, okay? So what they don't tell us is this right here. Okay? So we bring it down. Okay? It's kind of like our giant unknown variable. So if you take a look here, okay, well, if 18 is equal to 10 plus this integral, if you guys just go ahead and solve for the integral by isolating it, the integral from -7 to -1 of f of x dx, that whole thing should equal 8. So they didn't give us this fact here, but we were able to find it just by doing a little bit of math. Okay? Now I'm going through this in detail so that you guys can see the process, all right? So let me go ahead and squeeze in another page so that we don't lose our thought process here. Okay, so here's what we have so far. Okay, now if you read the question, you notice that that is not what they're asking for. It's slightly different. They're asking us, I'll put it in purple here. They're asking us what's the integral of f of x minus 1 from -7 to -1. So let me go ahead and write that down here. The integral of f of x minus 1 with respect to x from -7 to -1. You've seen this type of problem in the last homework assignment, or maybe 2, I can't keep track. But this right here allows you to split the integral in that you can keep the f of x by itself, but then you can also keep the 1 by itself. Okay? So here's what this does. If you take a look here, and hopefully I'll use the same colors, we actually now know what this value is. It's right up above right here. Okay? We now know that this is +8 according to our math upstairs there. Okay? So all that's left is to do a little bit of analytical components here. So the integral of 1 is really just x, okay? Because the derivative of x gives me 1, right? So the antiderivative of 1 would be x. And then you're going to go ahead and use the fundamental theorem of calculus here. I believe it's part 1. The parts really don't matter. As long as you know how to use it, you guys are fine. So what we do here is you have to plug in your upper first minus your lower. So in this case, it's going to be -1 minus, you plug in your lower, -7. All right? A lot of negatives going on here, so you got to be careful. Inside and this is just small details, okay? You end up getting a positive 6, and 8 minus a positive 6 will get you a positive 2. Okay, so I went through that in a lot of great detail, but obviously when you do it, you're going to be able to see the parts and you're going to be able to cut some corners there, okay? So just to recap, you had to have used that third property somehow, and that allows you to figure out one of these. You're going to be able to figure out one of those. And from that one, you should be able to tackle on the question that they're really looking for there, okay? So there's two parts to it. Finding the missing integral and then using that value to complete your problem. All right? So let's put this one to practice here. Let's try this one out. We'll call this part B. And you guys have this packet. If I end up not sending it to you guys via email or remind, please do text me right away, okay? Because I don't want you guys to spend all this time to write down the problem. All right, go ahead and try this on your own. Go as far as you can. And press play whenever you're ready, okay? Okay, so taking a look at the three integrals. Okay, the one with the largest spread or the largest distance, it's looking like -5 to +2, which is this one right here, okay? So we're going to start off with that one. I know that the integral, and we're just going to do f, okay? The integral of f from -5 to 2, that's the same thing as me breaking it up into two pieces here, in the two integrals. But I look at the value that they chose. They used -1 here. So I'm going to go from -5 to -1. And then from -1 to 2. Okay. And then we plug in what we know, right? So we don't know what this is. Okay. They didn't give that to us. But they did tell us that the integral from -1 to 2 is right here, and that is equal to 6, so I can go ahead and put 6 there, okay? And the integral from -1 to 5, sorry, -1 to -5 is -9, and I kind of have that there, but if you notice, the bounds are a little bit backwards, right? So if the integral of f from -1 to -5 is -9, then backwards, the integral from -5 to -1 must be +9. Okay? So that tells me that the integral of f from -5 all the way to -2 must be 15. Okay? So we take a look at this here. They're actually asking us for this. Okay, so we're looking for the integral of 4f of x dx from -5 to 2. Well, what you see right here, that 4 actually serves as a coefficient or a constant multiple. You guys know that with constant multiples, we can actually just push that constant multiple outside. And then take a look. We actually know what this is, don't we? Right? The integral of f from -5 to -2. Did I put -2? I don't know why I put -2. Crazy. Let me get rid of that. Okay, to 2 is equal to 15. So this is really just 4 times the 15, which is 60. Okay, a little bit easier than the previous one, but it serves the same purpose. You use that third property of integrals to figure out what one of the missing integrals is, and then you approach that question there. Okay, you find the missing integral and then you use it to solve for your answer. Okay, you guys will be able to practice a little bit more through the delta math, but that's enough to kind of show you guys how to get through it. But if you get stuck, remember, you could always let me know, okay? All right, here's part C. All right. And again, you guys have this all printed out, I hope. But if not, at least in front of you so that you can reference, okay? So, you know, a lot of learners that are mainly visual tend to have an easier time on this one, but I'm going to train you guys to take care of integrals visually, okay? So here's what we are going to do, okay? So they give you the function of f, which is this picture, and they're asking us determine which of the listed integrals is greater than the other three. So basically, they give us 4 of these integrals right here, right? And we have to figure out which one is the largest, okay? They might ask for the smallest too, so you got to watch out for that. Okay, so context. What does it mean to integrate? Right? Press play when you're ready. So remember that integrating is really just finding the area under the curve, okay? Or in some cases above the curve, but you're pretty much hugging the x-axis there, okay? So we're going to kind of eyeball it. So it's just a ballpark, but you should have a good sense of what it should come out to, okay? So for instance, here we go. And I'll color these in for you. Let's say we were to focus on this first one right here. We're finding the integral of f from -7 to 6. So remember, we're finding the area under the curve, respectively, from -7 all the way to 6. So if I were to color this in, from -7 to 6, -7 starts right here, and then you start accumulating area all the way until you get to 6. Okay? Some things you want to keep in mind. So we know that any area above the x-axis yields something positive. Anything below the x-axis gives you area that's in negative form. Okay? So although we can't put a number on it, I can say that this has a lot of positive area. So I'm just going to put a lot of positive. Okay? All right. So, and I might regret that by erasing it, but let's keep going. Now, if we were to just take the integral from 0 to 2, okay, what can you guys say about that? Press play when you're ready. So the integral from 0 to 2 in this case would come out something negative. So knowing that it's negative, I know that it's definitely not larger than the one that I started with. So I can actually rule that one out. Boom. Okay. So let's keep going. So now let's take a look at the integral from 2 to 6. Okay. The integral from 2 to 6 is definitely positive. Okay. But if you remember from -7 to 6, it had, I'll just color it quickly. So from -7 to 6, it had this, that, and this, right? So the way I see it is, this chunk here is probably about that much there. And if you add the same opposite area, they kind of cancel each other out, right? But notice how there's a significant amount of positive area left. Okay, so you have all this area, plus you have all of this. So what that tells me is that this down here, although it's a lot of positive, it's not as much as what I had from the very beginning. Okay? Now, depending on where you guys are, you might have to replay this a couple of times, and that's totally fine. Okay? Okay, here's the last one. We're going from The last one says from 0 to 6. So if I were to sweep from 0, whoa, did you guys see that? That was cool. From 0 to 6, I can definitely tell that I will have more positive area because this negative area here would probably be that much over there. I'm just eyeballing it. So I'm still left with a few positive area there, but not as much as what I started out with at the very beginning. So this one would have the largest amount. So it's a lot of analysis. There's not a lot of work to be shown. You kind of have to just mentally color it in to see what happens. But let's try another one. And here we go. Here's part D. Take as much time as you guys need, okay? Don't guess. Think rationally. Think logically here, okay? And then press play when you're ready. Okay, so I know the first one here from -3 to 0 will yield something negative there, right? Something less than 0, okay? Going from the next one, going from -7 all the way to +3. So let's take a look. -7 all the way to +3. I know I'm going to end up with something positive. It looks like these two are somewhat equal in opposite areas, so I know that these two will cancel out, but I'm still left with some positive area there. So I'll just put some positive. Okay, I don't know exactly how much, but again, we're just analyzing this here, okay? Before I move on, the big concept, you guys, is you have to understand that if you have the same area but opposites, when you combine that, it's kind of like adding opposite numbers, right? Comes out to 0. So you want to have that ability to kind of cancel out opposite areas, okay? All right, here's the next one. So we're going from 3 to 8. 3 to 8 is definitely negative, and I already have something positive there, so I know that that can't be it, and the first one can't be it, okay? So here's the last one. We're going from -3 to +3, okay? And again, although it's not exact, it looks like they cancel each other out in area. There's slightly a little bit more positive area than negative area, but I think we all agree that -7 to 3 is the winner here. It has the most positive area. All right, not a lot of work to be shown, just a lot of analysis there, okay? Okay, here's the last part. All right, I think I have 3. Okay, part E. Okay, the function f is shown below. Okay, make sure, train yourselves, you guys, that when you're looking at a graph, the first thing you should do is know what it represents. Okay, it's not always going to be the graph of f. Sometimes it's going to be f prime, sometimes it's going to be f double prime. Sometimes it's going to be h or h prime, right? You got to pay attention to what it represents. So this one here is super popular, especially on the FRQ section, the free response section, okay? So here we go. So if g is the function defined by, so they tell us that g of x is an integral from 1 to some number x I don't know, okay? Then they're going to ask you, what can we say about 3 things? What can we say about g of -5, g prime of -5, and g double prime of -5? And we'll tackle this one by one here, okay? So the first is the easiest one. If you have g of x and you want to know g of -5, naturally, what is your instinct there, right? Okay, so naturally what you would do is you would replace the x with a -5. So if I follow that equation there, I'm going to have this. All right? Okay, so if I take a look at this correctly, I'm integrating f, which is the graph, from 1 to -5. So when I'm integrating, I'm really just finding the area under the curve. Make sure that you guys understand that, okay? So I'm just finding the area, all right? Now, what I notice is that the bounds are a little bit backwards, okay? So I'm going to go ahead and reverse it as long as I account for a negative. Okay, so what I'm going to do, first I'll bring down that negative on the outside so that I don't forget about that. I'm going to have to eyeball what the integral of f is from -5 to 1. And remember, this means the area. Okay, so kind of like what we just did in the last example. So if I go from -5 all the way to 1, which is about right there, okay? And I know I'm scribbling, but really it's colored in because it's exact area, right? But again, you know, we don't have enough information about the function, so we're going to have to eyeball this one here. We're going to have to ballpark. Okay, so here's what I want you guys to think about. All of this in blue, would you guys say that this is positive, negative, or 0? Right? Press play when you're ready. Okay, so there's definitely, assuming that this is to scale, which it is, there's definitely more positive area than negative area, okay? This negative area right here would probably get canceled out by maybe this much positive area right there. So notice how we have a lot of blue left over, right? So I know that I'm going to get something positive in there. All right? So what you guys have to remember is, remember that negative that we took on the outside, right? So if you have some positive area multiplied by something negative, you're going to end up with something that's negative. Okay? So the fancy way of writing that is less than 0. We'll come back to that in a second. All right? Okay, so I'll write it over here actually. So now I know that g of -5 is less than 0. Okay. Only because I'm running out of space, I gotta get rid of this, okay? But you guys should have it written down. Okay, so here's the next one. We have to figure out what g prime of -5 is. So before I do that, let's figure out what g prime of x is, okay? If I know that g is the integral of f, what is g prime? So notice how I'm taking the derivative of an integral. Think about where we heard about that, okay? I'm taking the derivative of an integral. So this is FTC2, the Fundamental Theorem of Calculus Part 2. When you take the derivative of an integral, you get to do that really cool move where you just take the upper function and then you plug it in there. Okay? So remember, if the bottom is a constant and the top is a function, you're allowed to make this move, right? Okay, so g prime of x is really f of x. Okay, because if you integrate it and then you take the derivative, you're going to get back what you started with, right? Okay, so I want you guys to think about what the next part here is going to mean. So we want g prime specifically at -5. So that means g prime of -5 is the same thing as f of -5. Okay? So, what the heck is f of -5? According to our picture, right? Okay, so notice, when you get to the derivative, you end up with just f. And f is really just location, not area now. Because f of x, like f of -5 is right there. F of -5 is right there at 0. So g prime of -5 is equal to 0. That's just the y coordinate. -5 comma 0. Boom. Okay, so remember, g of negative 5 represented area, but when you got to the derivative, it represented location or point, whatever you want to call it there, okay? Okay, so I'm going to write that down as well. G prime of negative 5 is equal to 0 according to our graph. All right, so here's the last part. Okay, so we want to know what g double prime of negative 5 is. Okay, so we're going to take it one step further. So remember in that last part, we said that g prime of x was equal to f of x. So what if I want to find g double prime of x? Well then, I'm just going to have to take the derivative of this side, right? It's like, you know, if you were to look at this blue one, if you want g double prime, it's kind of like what you do to one side, you do to the other there, right? Which is how I got everything in purple. Okay, so g double prime specifically at negative 5 is what we're looking for. So that should be the same thing as f prime of negative 5. Ah, okay, so here's the biggest part. What the heck is f prime of negative 5? What do you talk about when you're looking at a graph, but then you're talking about a derivative? Really think about that before you continue this video. Okay, so remember, way back in first semester, when you're talking about derivatives, you're talking about the slope of a tangent line. That's the slope of a tangent line. So they're asking us, well, what's the slope at negative 5? Okay, so here's what you do. At negative 5, you draw a tangent line. Okay, now it may not be perfect, but what can you tell me about that slope? Okay, you notice that that line is leaning upwards, so you know that that slope has to be positive. Okay, so we are recalling stuff that we've been learning back in first semester, but we're really just creating bridges on what we've been learning. You know, we're just connecting what we've been learning so far. So here, I know that g double prime of negative 5, which is really just f prime of negative 5, we know that that is going to be something positive, or what we like to call greater than 0. Okay, that took a while to explain, but it's to get you guys to understand the thought process behind it. Actually doing the problem, piece of cake. So down below here, you guys have seen these type of problems before. You got to put them in order. So I know that this is negative, this is 0, and this is positive. So obviously the smallest value here will be g, then g prime, and then g double prime. So you're just looking for that down below. I believe it's the first choice. Boom. And that's it. All right. Okay. Here's part F. All right. Try this one on your own. Press play whenever you're ready. Okay. G of 4. G of 4, I just plug in 4 for x. So that's going to be the integral from 4 to 4. And remember, this is one of my favorite properties of integrals. When you're going from 4 to 4, you're not moving at all, so you're not accumulating any space. Remember, it's like you have no friends. So I know that this one will come out to 0. Okay? G prime of 4. So first, g prime of x, that's really just f of x, because we're taking the derivative of an integral, so that's just f of x. So g prime of 4 is really just f of 4. What the heck is f of 4 according to our picture, right? F of 4 looks like it's at 6. So f of 4 is 6, but definitely positive, right? Okay. let's keep going. One more. G double prime of 4. So I know that G double prime of x would be f prime of x, and that focuses on the slope. Okay, so I specifically want to find G double prime of 4, which is really f prime of 4. So I'm finding the slope at 4. So according to this graph, if I were to draw a tangent line at 4, I notice that it's a horizontal line, horizontal tangent line. So you guys remember that horizontal tangent lines have a slope of 0. Boom. Okay, so that one there, I think I cut out the screenshot there, but basically they ask you, G of 4, does it come out positive, negative, or 0? Same thing for here and same thing for here. It wasn't really put it in order like the last example, but you just have to figure out if each value came out positive, negative, or 0. Okay? So here's one more just to make sure you guys are on the right path. And then we'll call it a day. Go ahead and try this one here. Part G. Okay, so G of 6, we're finding the integral from -2 to 6. And what does that really mean? Well, integrating, you're just finding the area. So the area from -2 all the way to 6. Okay, so if you were to just eyeball this one here, it's looking like we have more positive area. Okay, so I know that G of 6 definitely comes out positive, all right? G prime of 6, or G prime of x, I should say, is f of x. Again, that's just the derivative of an integral, ftc2. So G prime of 6 is really just f of 6. And f of 6, according to my picture here, f of 6 is right there. And that's equal to 3. Okay, so definitely positive. And here's the last one. G double prime of 6. So G double prime of x should just be f prime of x, which is focusing on slope. So G double prime of 6 is the same thing as f prime of 6, or the slope of f at 6. So if you were to draw a tangent line here, coincidentally, it also becomes a horizontal tangent line. So you know that that slope will come out to 0. And that's it, you guys. A lot of analysis, not a lot of analytical work. There's a little bit, but that's it. Try it out on Delta Math. Let me know if you guys have any questions, okay?